Society of Ecology and Environmental Science, the 49th Annual Conference for Science and the Environment. I would like to say a few words in Hebrew before introducing Professor Pransin Leyden, properly in English. אחר צהריים טובים למשתתפי הכנס וברוכים הבאים למושב שבו פרופסור פרנסין ליידן תשתף איתנו את הידע המדעי על ההשפעות של שינוי האקלים וזיהום אוויר על הבריאות. פרופסור פרנסין ליידן היא פרופסור לאפידמיולוגיה סביבתית בבית הספר לרפואה לבריאות הציבור על שם צ'אן באוניברסיטת הרווארד, ופרופסור חבר לרפואה בבית הספר בהרווארד ובבית החולים בריגהאם ווימנ'ס. הרצאתה של פרופסור ליידן והמושב יערכו באנגלית, אבל אתם מוזמנים לשאול שאלות באנגלית או בעברית במהלך ההרצאה ב-Q&A, ואני אתרגם את השאלות ואפנה אותן באנגלית לפרנסין בסיום ההרצאה. Delighted to have with us Dr. Pransin Leyden, a professor of environmental epidemiology and the associate chair of the Department of Environmental Health at the Harvard Chan School of Public Health and an associate professor of medicine at the Harvard Medical School and the Brigham and Women's Hospital. Professor Leyden is currently co-director of the Harvard and Boston University Environmental Disparity Centers. And with the context of policy and science in our conference, Professor Leyden is a past member of the EPA Science Advisory Board and the past president of the International Society of Environmental Epidemiology. Her research interests focused on the environmental epidemiology of chronic diseases, including cancer, respiratory, and cardiovascular disease. Her research is focused on the following exposure: air pollution from ambient and occupational sources, persistent organic pollutant, secondhand smoke, climate change, and the built environment and green spaces. She has published key papers on the association of ambient particulate matters and all-cause and cardiovascular mortality in the landmark Harvard 6-city study and the Nurses' Health Study, and on the association of diesel exhaust exposure and lung cancer mortality in the trucking industry. I invite the audience to ask Professor Leyden questions in the Q&A box in English or in Hebrew during her presentation, and I will translate them. So without further ado, welcome, Francine.
Hi, I am Francine Leyden, Professor of Environmental Epidemiology at the Harvard T.H. Chan School of Public Health in Boston, Massachusetts. I am going to be talking today about the epidemiology of climate change with a focus on air pollution and temperature extremes. As you can imagine, this is a pretty broad topic with a growing body of literature. So I do not promise to cover everything, but hopefully I will give you a sense of the current state of the science and the approaches being used by epidemiologists to understand the human health effects of climate change. Before I begin, let me give you a quick overview of epidemiology. Epidemiology is the study of epidemics. In this case, we are interested in how the epidemic of climate change is affecting human health. When an epidemiologist sets out to perform a study, she must first define what outcomes she will look at. Sometimes this is deaths or mortality, and sometimes it is non-fatal events or morbidity. The outcomes are not always diseases. Sometimes they are conditions such as obesity or pregnancy outcomes. Then the epidemiologist needs to define the exposures she will look at. There are a lot of studies these days focused on temperature and temperature variability, or how much the temperature in a given time point varies from the normal, and on air pollution, all of which gives us insights into exposures due to climate change. The epidemiology of climate change is not limited to looking at these exposures, but it is what I'm going to focus on today. Finally, an epidemiologist estimates associations, or how the exposures are associated with the outcomes. She may calculate the risk of the outcomes associated with the exposures, or she may calculate the percentage of the cases of an outcome that are due to or attributable to the exposures. I borrowed this schematic from the 2018 report of the Lancet Countdown on Health and Climate Change, a collaboration of over 120 leading experts from academic institutions and UN agencies across the globe. I know this looks complicated, and I promise I will not cover all of this in the next half hour. What they are showing here are the different pathways by which climate change caused by greenhouse gas emissions up at the top can affect human health. I will walk you through what I think is important in this slide. First, the direct effects of greenhouse gas emissions are in the blue boxes: ocean acidification, temperature changes, and other air pollutants. In the dark red, changes in air pollutant concentrations caused by temperature changes, as well as adverse effects on biodiversity and agricultural productivity, are listed. The green box on the right lists social mediating factors which are affected by climate change. Different health effects are listed in the purple. I want to point out that this schematic should be updated to include more health conditions that we now are aware may be related to climate change. In this talk, however, I'm going to mainly focus on mortality and cardiovascular disease. And as mentioned in my title, I will specifically talk about raised and extreme temperatures and air pollution. I will not discuss food and diversity. Another way to look at all of this is that the impacts of climate change, which include warming temperatures, changes in precipitation, increases in frequency and intensity of exposures, and intensity of extreme weather events, and rising sea levels, affect all aspects of our lives: the weather we experience, the air we breathe, food we eat, and water we drink. In reviewing the epidemiologic literature, I found that there are really two foci of interest to epidemiologists. One is to study and assess the health risks associated with the specific consequences of climate change: temperature, temperature variability, air pollution, etc. And the other is to predict, based on the patterns of temperature changes that have been observed over the last decades, as shown in the map, what changes will occur in health outcomes, both in terms of numbers and in terms of identifying which populations are at the greatest risk. Much of this is summed up in the report from the Intergovernmental Panel on Climate Change. Just this January, the Lancet Countdown on Health and Climate Change updated their report. In one section, they focused on the climate change impacts, exposures, and vulnerabilities that I have been mentioning. As you can see from the quote on the cover, that accelerating trends were seen for each of the human symptoms of climate change, the outlook is quite dire. However, I don't think I need to convince this audience of that. This slide shows their analysis of heat waves and mortality. In the uppermost graph, you can see that throughout the world, the number of days of heat wave exposures, which is depicted on the y-axis, has been increasing since the 1986 to 2005 baseline, as shown on the x-axis. In the bottom graph, you can see a clear trend of increasing health-related deaths among the population over 65 years old, consistent with the pattern in the first graph. The authors of this study pull out some important numbers, which I have presented here. The bottom line, though, is that heat-related mortality in people greater than 65 years old increased by 54% from 2000 to 2018 throughout the world. A common metric that epidemiologists use to study heat waves is temperature variability. In this study, the researchers calculated the temperature change between neighboring days. They refer to this as TCN, but basically we're looking at temperature variability, and related it to daily mortality in 106 communities in the US between 1987 and 2000. The gray lines show the effect of temperature variability on mortality for each of the communities studied. And the red line represents the combined result for all cities. The blue shows the error around the pooled estimate. The authors found an increasing curve for the temperature variability mortality association, indicating that when temperature decreased from the previous day, mortality risk was reduced, and when it increased, there was a higher risk of mortality. This slide depicts another study in the US looking at temperature and mortality. In this study, the researchers examined the associations between temperature and mortality over 6-7-year periods from 1962 to 2006 in 211 cities scattered throughout the United States. They did not look at extreme effects, but rather on the continuous effects of temperature. First, as you can see in the map, they clustered the cities by weather characteristics, including temperature and humidity, which are depicted by the colors. For example, the pink cities in the southern US are hot and wet, and the yellow cities in the north along the Canadian border are cold and dry. Moving to the plots at the bottom of the slide, both of these graphs show the risk of death on the y-axis compared to temperature. The one on the left looks at temperature on the day of death, and the one on the right plots the average temperature for the past 5 days. On the left, we see increasing risks of death with increasing temperatures on the day of the event with different curves for different cities. For example, the orange cluster, which has milder climates along the Pacific coast, has a relative risk of 1.14 for the temperatures of 27 degrees Celsius versus 15.6 degrees Celsius. And the light blue cluster, cities in humid subtropical climates with hot summers along the Gulf of Mexico, has a relative risk much lower of only 1.04. Significant differences were also found for the cold effect. For the pink cluster, which is in the warmer southern United States, the relative risk was 1.12 for temperatures of 4.4 degrees Celsius versus 15.6 degrees Celsius. Whereas for the royal blue cluster, where winters are usually cold and long, the relative risk was much lower, again, only 1.07. The figure on the right shows that the increase in mortality rate at -10 degrees Celsius rises substantially across clusters as the frequency of colder temperatures in the cluster decreases. These differences, by usual climate pattern, provide evidence that people acclimate, or in other words, get used to the norms of the climate in which they live. One of the existential questions facing climate change epidemiologists is the relative importance of temperatures that are too cold versus those that are too hot. In the study depicted here, the researchers examined the total mortality burden attributable to non-optimum ambient temperatures and the relative contributions from heat and cold in 384 locations across 13 countries and regions. This graph depicts the fraction of all-cause mortality attributable to extreme cold in the dark blue, moderate cold in the light blue, moderate heat in the pink, and extreme heat in the red in each of the countries. They found that most of the temperature-related mortality burden was attributable to the contribution of cold, and the effect of days of extreme temperature was substantially less than that attributable to milder but non-optimum weather. The authors conclude that their results suggest that public health policies need to take account the whole range of temperature exposures. So it's not just the extremes that are important. This graph is the first in a series of forest plots that I'm going to show you from a review of reviews of the epidemiologic literature on the epidemiology of temperature and morbidity and mortality. This plot shows the main results from studies of heat exposure on morbidity or non-fatal outcomes. They are grouped by disease in the left-hand column, and the total of estimates, number of estimates included in each study, which is basically the number of studies that were included in that review, and is listed. And then the primary relative risk and 95% confidence intervals are presented. The vertical line at 1 represents the null result, and dots or estimates to the right of the line indicate a positive association of heat or increasing temperatures with that disease. Confidence intervals, which are the horizontal lines, show the amount of confidence that we have in those estimates. Those that do not cross the vertical line are considered statistically significant. Generally, this forest plot shows that heat has an adverse effect on morbidity from the various causes presented. This is the equivalent plot for mortality. There are fewer studies here, but again, heat seems to have an adverse effect on health. Now remember, this is a review of reviews, so actually you can see how many studies are presented, which is in the number of estimates. So it's just there are fewer reviews. But again, these are really very statistically significant consistently. This is the forest plot for the slides for the studies of cold exposure on morbidity. And this is the forest plot for cold exposure and mortality. Again, there's very strong, consistent evidence that both heat and cold are associated with adverse health outcomes. So, as I mentioned before, one of the big questions that climate change epidemiologists want to know is if warming temperatures will lead to a decrease in cold-related deaths, which will then offset the increase in heat-related deaths. This slide shows predicted trends in heat-related and cold-related excess mortality under 3 climate change scenarios by region. The 3 scenarios represent mild to extreme changes in global warming from left to right. So here I focus on the bottom part of the grid, not because I'm particularly interested in these countries, but just to make it easier to see. But basically it appears that decreases in cold-related deaths will likely be overshot by heat-related deaths, particularly in the model which predicts the most warming, obviously. But there is strong geographical variability. Some temperate areas, such as Northern Europe, East Asia, and Australia, are characterized by a relatively small projected warming and increase in heat-related mortality. And you can see Australia's here in these 3 countries, these 3 areas that I present. As with most environmental exposures, there are considerable disparities in the health effects of climate change. In other words, different populations are affected by temperature and other climate change effects in different ways. And what influences the ways that these differences are basically threefold: exposure, sensitivity, and adaptive capacity. I'm sure it is no surprise to hear that the populations that are the most impacted by climate change are the ones who have least contributed to the problem. For example, underdeveloped countries are being most affected by food insecurity and decreases in biodiversity, but they are not the countries which are the major users of fossil fuels. Likewise, disadvantaged people in developed countries are not the ones driving around the most or using air conditioning. Climate change is one factor that makes these disparities worse, and epidemiologists have observed differences in the effect of temperature and other markers of climate change between groups defined by existing social and economic inequalities. I have listed here examples of groups of susceptible or vulnerable individuals: pregnant women, individuals with pre-existing conditions, elderly and very young, people with lower socioeconomic status. It is important for epidemiologic studies to consider these groups when analyzing their data, and it is important for policymakers to take the most vulnerable populations into account when determining regulations and strategies for combating climate change. Along these lines, urban characteristics play an important role in modifying effects of temperature. In this 2019 study in the United States, all throughout the world, the researchers analyzed the association of ambient temperature and daily mortality in 340 cities in 22 countries. They calculated the fractions of mortality attributable to heat and cold, it's labeled as the AF %, and determined which city indicators modified the effect of heat and cold. Their main observation was that heat-related deaths amounted to 0.54% of total mortality, and cold-related deaths were 6.05%. However, as you can see from the forest plots on the left and highlighted in the text on the right in the box, the mortality effects of heat were higher in cities characterized by greater population density, gross domestic product, income inequality, and air pollution. And the effects were lower in cities with more green spaces and more availability of health services. No clear modifiers of the cold mortality association stood out. Here I go into a little more depth on green space and climate disparities. The figure on the left shows raw temperature data along a portion of one transect in Madison, Wisconsin. As you can see from the pictures, there is fine scale variation in air temperature with changing land cover. On the left, you see a picture of a tarmac, basically, where the temperature is 31 degrees Celsius. And then moving towards the right, you see more green areas and the temperature is going down to 27 degrees Celsius in the leafy green area. On the right, I have selected one city, my home, Boston, Massachusetts, from an article that came out in the New York Times just a few days ago. This shows that there are socioeconomic disparities in urban green spaces. Areas with higher median outcomes have higher levels of green space. Even though it is not depicted here, there are also racial disparities in exposure to green space. Thus, green space both reduces exposures to temperature and also when it is unevenly distributed throughout urban areas, it contributes to racial and socioeconomic disparities in exposure to high temperatures. Green space can be one mechanism by which more disadvantaged people are exposed to higher temperatures. Now I would like to give a very short presentation on air pollution. Particulate air pollution is the most commonly studied pollutant, particularly PM2.5 or fine particulate matter less than 2.5 microns in diameter. This size fraction is small enough to get deep down into the lung and has been implicated as a major contributor to all-cause mortality, cardiovascular diseases, lung cancer, and a host of other diseases and outcomes. On the left-hand side of the slide, I show a human hair in order for you to be able to see kind of the relative size of PM2.5 and also of PM10, which is larger particles that are 10 microns in diameter and less, which are called coarse particles. Then on the right, I have a little schematic that shows the total deaths from ambient particulate pollution worldwide are estimated to have increased from 2.95 million in 2015 to 3.0 million in 2018. So air pollution is a major contributor to the disease burden in the world, and its effects are increasing over time. Down at the bottom, I show graphs illustrating the different sources of PM10, the coarse particles, and PM2.5, the fine particles. You can see the contributions particularly from fires, industrial processes, and combustion, sources which are associated with climate change. Ozone is another air pollutant that is measured in air pollution studies. Ground level ozone levels have been associated with health impacts. Ozone-related health impacts depend on 1, the amount of pollutants emitted that form ozone, and 2, the meteorological conditions that help determine the amount of ozone produced from these emissions. Both of these factors are expected to change in the future. The emissions of pollutants that form ozone, otherwise known as precursors, are expected to decrease over the next few decades in the places like the United States. However, irrespective of these changes in emissions, climate change will result in meteorological conditions more favorable to forming ozone. As shown in the schematic, higher temperatures, sunnier skies, and lighter winds lead to higher ozone concentrations by increasing the rate of chemical reactions and by decreasing the extent to which pollutants are mixed with clean, less polluted background air. On the right, I present results from a study in the United States Medicare population, a nationwide study of individuals over 65. These are the concentration response functions of the joint effects of exposure to PM2.5 on the top and ozone on the bottom on all-cause mortality. The graphs show that people die more when PM2.5 and ozone increase. Here I spell out the climate penalty that I described in the previous slide. The factors that lead to increasing temperatures are emitters of pollutants into the air. However, in addition, the increasing temperatures associated with climate change make for conditions that also lead to higher air pollution. Higher temperatures lead to higher ozone. Precipitation and humidity affect PM 2.5, and wildfires and dust storms increase particulate exposures. This figure is from another study where the investigators predicted changes over time using different climate scenarios. In the first column, we see changes in average daily maximum temperature across the United States for the two different scenarios. The middle column shows the subsequent estimated changes in daily ozone in the summer season, which is when ozone is high. And then the third column shows the anticipated deaths attributable to ozone in 2030. Definitely varies in different areas of the country and in different areas of the world. And there's definitely evidence of increased exposures as well as some increased risks as well as some decreased risks. In this slide, I present an example of a US nationwide study looking at the associations of air pollution with cardiovascular disease morbidity and how these associations differ depending on greenness, temperature, and humidity. There are many studies out there like this. This just happens to be a recent publication out of my group. We used the Medicare hospitalization database and assessed association of cardiovascular disease hospitalizations with exposures to PM 2.5, NO2, and ozone. The table in the middle shows the main effects of elevated risks with increasing levels of PM 2.5 and NO2, but not ozone in the full population. However, the associations were stronger for all three pollutants when only low exposures were considered. This is particularly important when we consider the government's desires to set regulatory standards. It shows that it's really important to get levels as low as possible. The graphs on the right show effect modification by NDVI, which is a measure of greenness, summer temperature, winter temperature, summer humidity, and winter humidity. Decreases in summer and winter temperatures and specific humidity were associated with stronger PM 2.5 associations and to a lesser extent, NO2 associations. Our results are in contrast with the study that reported stronger associations between long-term PM 2.5 and mortality in cities with high temperatures in the US. However, several studies reported stronger associations of short-term exposure to air pollution with cardiovascular hospitalizations on cold winter days. Moreover, some studies showed stronger associations for short-term air pollution with decreasing humidity. Basically, the bottom line is that studies are seeing lots of different associations, and really understanding how temperature and air pollution interact is a really important question that researchers are still spending a lot of time exploring. The study of the health effects of climate change is a large and complex field, and I didn't even attempt to cover all of it. These are the main take-home messages from what I covered today. First of all, the primary metrics that climate change epidemiologists focus on in their studies are temperature and temperature variability. And they are looking at their effects on a whole slew of diseases and causes of death. The interplay of cold versus hot temperatures on human health is important and needs to be further understood, particularly the trade-offs of reduction in cold-related deaths with the increases in heat-related deaths due to climate change. Air pollution is one of the leading causes of disease burden in the world, and it is linked with climate change. There is evidence of considerable health disparities associated with climate change due to differences in exposures, sensitivity, and adaptive capacity. And the factors driving these disparities need to be considered in all analyses of the epidemiology of climate change. I would like to end with this quote from an article this past weekend in the Washington Post about the extreme heat wave that just hit the West Coast of the United States. It will be months before experts know precisely how many of those deaths can be specifically attributed to climate change. But researchers who specialize in the science of attribution, otherwise known as epidemiologists, say they are virtually certain that warming from human greenhouse gas emissions played a pivotal role. It is a sign of how dangerous the climate crisis has gotten and how much worse it can still become. Thank you.
Thank you, Professor Pransin Leyden, for a wonderful and intriguing presentation on the health impacts of climate change and air pollution to our non-epidemiologist audience. I would like to ask you a few questions. There are questions from the audience, but I would like to be the first one to take a question for myself. So, as the former president of the International Society for Environmental Epidemiology and as a leading scientist in the environmental epidemiology field, do you think that the role of the International Society and our role as a scientist is to translate our knowledge to policymakers and to the general public? And do you think that we're doing enough?
Well, that's an easy question. Yes, I do think that it is our role, and no, we are not doing enough. I just actually left the policy committee from the International Society of Environmental Epidemiology, where we were talking just that, about how can we as scientists make sure that the messages from the epidemiology studies, the risk assessment studies, exposure assessment studies, how does that really get to the politicians, to the rule makers and the regulators, so that they can really understand and move to the next step? And we're struggling with how best to do that, how to really get movement, but I think it's incredibly important.
So if you had a chance to recommend to the policymakers in Israel, and there are a few in the audience, do you have any idea what are the best action and intervention that can work to mitigate and to adapt to the risk of climate change?
I think that's a good question. I mean, what we're seeing obviously is that we know now that climate change is happening. I don't think that is a question. And I think there's not a question that it's man-made. However, I don't even think it matters. The point is that how do we try to slow it down? And I think a lot of and Israel is a really great place where this is happening with alternative fuels, with solar energy, with other sources of trying to get at, the fuel that we need to live modern life in order to decrease and use those and get them much more important in order to decrease the rise in the temperature changes. So I think really focusing on that and about the co-benefits of climate change in terms of what can we be doing that's really going to also help in other ways, help the planet. So I think that's really important.
So do you mean mitigation action?
Yes.
Or?
I think mitigation actions and obviously making it so that there's less reliance on fossil fuels.
Relating to the mitigation action, so do you think that there are mitigation action that can we pursue that? Sorry, I'm the questions.
I mean, I think that there are definitely out there. Again, as an epidemiologist, I'm kind of more studying what it is that is the problems, and I'm sure there are people in this audience who better know like what it is that we need to really focus on in order to get this.
So if we know the problems, let's not focus on the solution. The problems. Do you think that how can we communicate the complex result that you presented, that it was very challenging, I assume, but it also, you did it very fast forward. And how can we communicate the uncertainties that there are in the epidemiological studies? And do you think that there are things that we are certain about and we can definitely say that?
Well, I think what we are pretty certain about at this point is that temperatures are changing, and that those temperatures are associated with increased mortality, with increased morbidity. And so we are definitely there, not only in the models that are projecting forward, but in the looking backwards, we're definitely seeing effects on human health that are associated with these changes. And I think, along those lines, it's not just in terms of temperature and in terms of air pollution, but changes in food availability, in biodiversity that is affecting the way everybody lives, and whether people can continue to live in the areas they're living in now, or if there needs to be migration into other areas. I think we're already seeing those patterns and really understanding how that is affecting affecting humans right now, and how it can, and really kind of telling the story and making it very clear that this is imminent about how there are going to be changes going forward.
One thing that I'm very interested in, for you as an associate professor of medicine at the hospital, at the Barigham and Women's Hospital, to the best of your knowledge, do physicians and nurses study about the health effects of climate change or other environmental stressor during their early years of training?
You know, in my capacity as associate professor of medicine, I'm not particularly teaching them that, but because I don't really teach in the medical school, even though that's my title. But I am now finding that there are many, many more physicians that are talking to their patients about these questions. So they're asking the questions so that they can help inform their patients. Particularly, you know, as it's become more in the news and other things like that, people are really wondering about that. And I was actually just literally looking at an editorial that was written by a physician about one of the anxiety around climate change and about how to, you know, kind of calm down and understand about it. And so then make that anxiety move to action and have, you know, the regular, ordinary people who are not the scientists really clamoring for their politicians and regulators to be making this a front and center concern.
So you're giving a very important point about not to frighten the people.
Right.
To give them more possibilities for solutions and not just to tell them how bad it's going to be.
Exactly.
That we also need to communicate to
I think that's really important. And it was in a discussion that people were having in regards to this latest, you know, in the United States, particularly, there was this major heat wave. I mean, we had, you know, 117 degree temperatures in Fahrenheit on the west coast of the United States, where usually it's 70 degrees Fahrenheit. So it's a major difference. And about how people it's just as much as the health effect of the heat, there was the health effects of oh my God, what is happening here? And, you know, so I think, unfortunately, once things like that start to really happen, people really understand the importance of this. And it's not just something in the future that's not going to affect us for a number of years, or, okay, it's not me, but maybe a couple generations later. It's when it's starting to really affect us right now, we really see the urgency.
So there are also a few questions in the Q&A. One of them is related to Israel. So the already warm countries like Israel, Iraq, Nigeria, and India are the ones where population growth is highest. Would you expect people from warm countries to immigrate to cooler countries?
I think that's a really interesting question. I think we already do see some within countries, a bit of migration. You know, I think, you know, there are people who are saying, you know, I don't want to live in this, you know, as the temperature changes, but there's also adaptation that happens. And so, you know, I mean, moving from, you know, Israel to Norway is going to be a major difference, right? It's not so easy. Like, the climate is not your only decision-making criteria. So I think that there is adaptation. I mean, some of the slides that I showed do show that people do tend to adapt. I think, you know, it's possible that lifestyle may change before people are going to change from one country to another.
Maybe also desertation, when people are completely need the water from the rain, they are much more dependent than in Israel, for example.
Yes.
So there is one very interesting question, I think. How do rising temperature and other climate change affect two other outcomes: disability, chronic and temporary, and fertility? So what new disease vectors should we expect?
I think there's so many out there. I mean, that is one of the things I did refer to when I said that I was going to just talk about mortality and primarily cardiovascular disease. You know, the literature on fertility and birth outcomes is really growing in terms of air pollution specifically, which, as I mentioned, is related to climate change. But there's also a growing literature on heat effects and fertility. So, I think it's very integrated. Like, is it heat directly that might affect fertility? Is it that heat may affect, family planning or family decisions that people are making? Heat might affect, the diet that people are eating that then could affect fertility. So there's a lot going on, and there's really a lot of interest. Fertility and birth outcomes have become like one of a major risk, a major outcome, it's not really a disease, but a major health endpoint that people are really focusing on these days.
Yes. I have to mention my study on Israel, where we do see the association between the heat temperature and the cold temperature and birth weight. We analyzed more than 600,000 births in Israel. So we see this association of two of the extremes of cold and heat. Mm-hmm. So I think we need to finish, Francine. It was fascinating and it was wonderful. And thank you so much for showing us and presenting us all this knowledge for all the audience that is not epidemiologists. And we do hope to see you soon in Israel. We're very
happy to get there soon. So thank you very much for having me.
Thank you very much.
הכירו את דוקטור אורן שלף, אקופיזיולוג של צמחי מדבר. אורן הוא בוגר מחזור ג' של ממשק.